For this review video, we're going to look at solving quadratic equations. And so we talked about three methods of being able to solve quadratic equations. Square root method, factoring, and the quadratic formula. And so this first problem here, when I look at it, the first thing that comes to my mind is by factoring. So I'm going to do factoring, 25x squared minus 9 equals 0. What I see is this is perfect square minus a perfect square. And so that is going to have me do 5x plus 3 and 5x minus 3. And then if I take and set each of those factors equal to 0 and solve, I would end up with x is going to equal a negative 3/5 and x will equal a positive 3/5. If you looked at this problem and you thought, hey, that is missing the middle term, that bx term, you can do square root method with it. That would be a correct way to go also. And so if we did that, we would take and isolate this square by moving the minus 9 to the other side. Since it's 25 times x squared, we'll divide both sides by 25. And then since we have x squared, we square root both sides. Make sure we put plus or minus in there. Square root of 9 is 3, square root of 25 is 5. You can see that we have the same answer here by square root as we do by factoring. You can even, if you wanted to, you could say that a is 25, that b is 0, and that c is negative 9. And you could do the quadratic formula. So we'd start with our discriminant, and we would say that b squared minus 4 times a times c would give us 4 times 100, 900. Positive discriminant tells us to keep going and find our x-intercepts. So x is equal to the opposite of b, which is 0, so I'm not going to write anything there, plus or minus the square root of 900 divided by 2 times a is 25, that's going to be 50. The square root of 900 is going to be 30. We have 30 over 50. If we divide that, we're going to get that x is equal to plus or minus 3/5. And so you can see that we've done the problem by factoring, difference of two squares, by square root method because it was missing the middle term, and then by the quadratic formula. All right, in our next problem, looking at it and thinking about our three methods, I know immediately that I cannot do the square root method because the presence of that 10x. So I know that I'm either going to have to do factoring or go to the quadratic formula. If I look at factoring, this one factors pretty easily. Two numbers that multiply to 9 and add to 10 would be x plus 9 and x plus 1. And if I take this factor, set it equal to 0 and solve, I have an intercept at negative 9. Here I have an intercept at negative 1. If you decided to do quadratic formula, our a would be 1, our b would be 10, our c would be 9. If we go to do the discriminant, that would be b squared minus 4 times a times c. And so when we have that, that is going to give us a 64. 64 tells us two things. It tells us first it's positive. So positive discriminant tells us there's going to be two intercepts, but it's a perfect square, which tells us it's factorable. So if you wanted to, you could go back and try factoring. If you wanted to keep going with quadratic formula, you can do that. And so it would be x equals the opposite of b plus or minus the square root of 64 divided by 2 times a. That'll be negative 10 plus or minus 8 divided by 2. And then we're going to have negative 10 plus 8 divided by 2. And that is going to give us a negative 1. And then negative 10 minus 8, negative 18, divided by 2, that is going to give us a negative 9. And you could see that whether you do the problem by factoring or by the quadratic formula, we get the same two intercepts. Okay, our last problem, when I go to look at this, the first thing I need to do is make sure that it is in standard form, which means it's set equal to 0. So I'm going to do that first. And then I'm going to decide, you may decide that you want to try to do factoring. This would be trial and error. What I see in working with students in class is that most people would automatically just go to say that they're going to do quadratic formula with when we have a trinomial in which a doesn't equal 1. So a is 4, b is negative 5, c is negative 1. If I go to do the discriminant, I have b squared minus 4 times a times c. That'll give me a discriminant of 41. Positive discriminant tells me keep going. There's going to be 2 x-intercepts. The 41, since it is not a perfect square, told me that I made a good choice in going straight to the quadratic formula because this would not factor. So looking at this, if I think about factoring, even if I tried trial and error, that would not work. I know that I couldn't do the square root method here because it had the middle term in there, it had the x term. This was when quadratic formula is the only way to go. So I'm going to start x equals the opposite of b. B is negative 5, the opposite of it is positive 5, plus or minus the square root of 41, divided by 2 times a. A is 4, so 2 times 4 is 8. And then this becomes a calculator problem from here. I'm going to have 5 plus the square root of 41 divided by 8, and 5 minus the square root of 41 divided by 8. And remember, we round to 2 decimal places if we don't have any other directions. And so we have 2 intercepts now, one at positive 1.43 and one at negative 1800, so negative 0.18.